Okay, this is screencast number 4 for lesson 4 of unit 6. And I'm on page 314 in lesson 4. So it says, what are telescopes? Well, hopefully you guys have at least a vague idea of what a telescope is and what it looks like. A telescope is an instrument that's used to collect and concentrate electromagnetic radiation. Well, that might sound fancy, but remember that visible light is one type of electromagnetic radiation. And so if you're thinking of just visible light, a telescope would be an instrument that's used to collect and concentrate visible light. Okay, but there are other types of telescopes besides just optical telescopes or telescopes that collect visible light. Okay, optical telescopes are by far the best known types of telescopes to the general public because they were developed first, and they are what the general public tends to use the most often if you're talking about a telescope. But there are other types of telescopes that collect electromagnetic radiation that's not visible to us. What those telescopes do is they pick up X-ray radiation or gamma rays or radio waves or infrared rays or ultraviolet rays and collect that data. And then that data typically is sent to a computer, and the computer generates an image that's sort of like a map of areas of high and low intensity of those wavelengths. And they create a map that we can see with our eyes, but it's based on either infrared or radio waves or whatever type of radiation was picked up with that telescope. Okay, so first we're going to talk specifically about optical telescopes, meaning the type of telescopes that we can use to collect visible light. Okay. So we're down here. What are two types of optical telescopes? Optical telescopes either are going to use mirrors to reflect light or lenses to refract light. Okay. The two basic types of optical telescopes are reflecting telescopes, which uses mirrors, and refracting telescopes, which use lenses. Okay. All right, so down here we have a depiction of your basic type of reflecting telescope. They're basically set up this way. You have a long tube that's empty, and you have a mirror placed at one end of the tube. Now the mirror is a curved surface, kind of like the bottom of a bowl. Okay, so a reflecting telescope uses a curved mirror to collect the light. The mirror is curved so that when the light comes in, it hits that bent mirror and it starts to focus towards a particular point. Okay, so the light comes in, bounces off the mirror. You can see that it begins to focus. It then hits another mirror that's typically mounted in the middle, right here, and it's at an angle. So it takes this light coming back, bounces it, and turns it 90 degrees, so it'll go out this eyepiece. And the eyepiece helps to focus the light so that you can see it. Okay. The larger the mirror, the more light you can collect, and that's true of refracting telescopes too. The larger the lens, the more light you can collect. Large mirrors typically are used to collect more light. The Hubble Space Telescope is a type of reflecting telescope. The Hubble Space Telescope is actually a telescope that we have out in orbit around Earth that scientists, control remotely by computers to aim it at certain things and look at all sorts of things. Okay. Okay, so over here, what are optical telescopes? Optical telescopes are telescopes that collect visible light, meaning the parts of the electromagnetic spectrum that we can pick up with our eyes. Okay, and you need to remember that bigger telescopes can gather more light, and because they're able to gather more light, their images are better. So the bigger the telescope, the better the image is usually. It doesn't always mean that it's a bigger image, but it's a crisper, sharper image. Okay. Okay. So we talked about the first type of optical telescope, and that was the reflecting telescope. By the way, I put Newton by reflecting telescope because Isaac Newton was the first to develop the reflecting telescope, so he's credited with that. All right, we're going to go to page 315, and we're going to talk very briefly about the refracting telescope. A refracting telescope uses a lens to collect and focus the light. And if you're using a lens, when light passes through a lens, it bends or refracts. That's why it's called a refracting telescope, okay? Because a lens is going to refract. It's going to bend the light, okay? This type of telescope was developed primarily by Galileo. He was the first one to look at Jupiter and see that Jupiter had little bitty moons orbiting it, things like that. Okay, so the big difference, once again, a refracting telescope uses a lens to focus light, whereas a reflecting telescope uses a mirror to focus light. Okay. Okay. Before I answer this question, I'm going to talk about this. Where are telescopes located? First of all, telescopes typically are going to be located away from cities. If you're talking about, like a large research facility that has a telescope, they're going to typically locate them away from cities because there's a lot of light pollution in the cities. If you've noticed, if you've ever been in a big city at night, you have trouble seeing very many stars, and that's just because of all the light pollution that's in the city itself. It's all the street lights and things like that. So we want to get away from the light pollution from the cities and things like that. But we also want to get as far up as possible because we want to get out of as much of the atmosphere as possible, because the atmosphere interferes with our ability to see very well also. The reason why stars twinkle at night is because of the effects that the atmosphere has on the light that's coming through it. So if we're going to put together a really powerful telescope that we want to be able to use, we would like to place it somewhere where we don't have to deal with as much atmosphere. So a lot of times they're going to be placed at higher elevations, up in the mountains or things like that, where the atmosphere is thinner. Some telescopes, including the Hubble Space Telescope, are actually placed in orbit, so they're out of the atmosphere altogether, so we don't have that to contend with. Okay. I am going to point out that large optical telescopes are typically reflecting telescopes, and that's just because, and I'm not going to get into the reasons why, but reflecting telescopes are easier to build, and they're just easier to build, which is why we typically make large telescopes out of mirrors rather than lenses. Okay, number 14 asks us, how do reflecting telescopes and refracting telescopes differ? Remember that a reflecting telescope uses reflection with a curved mirror, and a refracting telescope uses a lens to bend the light. But both of these types of telescopes, both reflecting telescopes and refracting telescopes, are collecting visible light that we can see with our eyes. And just keep in mind that the light we see with our eyes is only one type of electromagnetic radiation. There's a lot of other types of electromagnetic radiation. And for us to get a complete picture of what's going on in the universe, we need to not only look at what is going on with visible light, but we also need to collect images based on the electromagnetic radiation that objects are giving off. Maybe if it's radio waves or infrared or ultraviolet or X-rays or what have you. That gives us a more complete picture of what that object is actually doing.